Hello everyone. The question is six charges are placed around a regular hexagon of side small a as shown in figure. Figure is this. This is the regular hexagon and side is the A and center is the O. There are the five charges are given. First charge is Q, first charge Q, second charge Q, third charge Q, fourth charge Q and fifth charge Q. Also sixth charge is the X. Let us suppose sixth charge is the X and this charge is the equidistance from the O point to Q charge, O point to Q charge and O point to Q charge. Also, this is the line joining from O to charges and this is the perpendicular bisector to the sides. Let us suppose this is the A side and this is the charge Q and this is the perpendicular bisector. This is the perpendicular bisector. Also this is the perpendicular bisector and also this is the perpendicular bisector and also this is the perpendicular bisector. Okay, and also given five of them have charge Q. Five of them had charge Q and remaining one charge has small x. This is the sixth charge and this is the five charge. The perpendicular from each charge to the nearest hexagon side passes through the center O and hexagon and it's bisected by side. This is the perpendicular bisector bisected by the sides. This is the perpendicular bisector and this bisector is bisected by side. Bisected by side means if this is the A point and this is the O point and this is the P point, then the distance from A to P equal to the distance from P to A. Implies that this side is equals to this side. Implies that we can say AP equal to PO or we can say PO OP equal to PA. So this is the equidistance. If this side is the 4 meter, also this is the 4 meter. Also this case will be valid for each cases. There are the 6 cases. First case is this and second, third, fourth, fifth and sixth. This is the identical cases. This is the x distance, then also this is the x distance. This is the 4 distance, also this is the 4 distance. This is the 10 distance, also this is the 10 distance. Implies that we can say we have to need. There are the given option is this A, B, C and D. This question is the advanced 2022 questions. Also this is the advanced 2022 questions. Then these questions are the more than the one options. A option, B, C and D. Then check the option one by one. The first option is this. A option is the when x is equals to q, then find the electric field at point O equals to 0. And if x equals to q, option A is this. Option A says that if value of x is the charge, if x equal to q, then net electric field at point O, magnitude of net electric field at point O equal to 0. So according to figure, if x is the discharge, imply that we can say x equals to q. Let us suppose according to option A, x charge is equals to q, imply that we can say we know that we have to need the net electric field at point O due to these 6 charges. We also knows that if we need the electrical field due to charge q, we have to need the electrical field due to charge q. This is the P point and also this is the A point. We have to require the electrical field at point A due to q charge, which is the if charge q is the positive. This is the given. Charge q is the positive, then direction of electrical field will be the away the positive charge, or we can say direction of electrical field will be the line joining to charge and that point, and if charge is the positive, then that is the away. If charge is the negative, then that is the direction of electrical field will be towards the charge. Here charge is the positive, imply the direction of electrical field at point A will be the away. Also, if charge is the negative, then direction of electrical field at point A will be towards. But here charge is the Q is the positive, so direction of electrical field will be away. This is the direction of electrical field. And the value of electrical field which will be equals to 1 upon 4 pi epsilon naught Q by R square. R the distance between P to A, imply that we can say PA whole squaring. So we can say net electrical field which will be equals to 1 upon 4 pi epsilon naught Q upon PA square. Similarly, we can say electrical field we can superimpose, imply that we can say if there are the three vectors as given, then sum of these vectors which will be equals to, directionally we can say E1 vector plus E2 vector plus E3 vector. If four vectors are given, let us suppose E1 vector, E2 vector, E3 vector and E4 vector, implies that we can say sum of these vectors which will be equals to E1 vector plus E2 vector plus E3 vector plus E4 vector. Imply that we can say we have to need the value at this point. So this is the first charge. Let us suppose this is the first charge, this is the first charge, and this is the second charge, and this is the third charge. Also this is the fourth charge, fifth charge, and sixth charge. We have to need the electrical field at point O. Due to A, or we can say due to first charge, we have to need the electrical field at point A. This is the directionally will be the away. This is the plus charge, and we have to need the electrical field at point O. This is the directionally which will be equals to E1 vector. Imply that we can say similarly due to the second charge is this Q charge. If we have to need the direction of electrical field which will be the away, this is the E2 vector. Similarly, we can say due to third charge, the value and direction of electrical field at point O which will be the away. This is the, let us suppose this is the E3. Similarly, we can say this is the fourth, due to fourth which will be equals to, this is the E4. Imply that this is the fifth vector, this will be equal to E5. Imply this is the sixth charge which will be equals to, this is the E6. So we can say we have to need the net electrical field at point O which will be the algebraic sum. Or we can say here we are try to find out the distance between charge and O point. Charge and O point means E1 vector magnitude. E1 vector magnitude. So we can say E1 vector magnitude. E1 vector magnitude means we have to need the distance between that two vectors, E1 vector, which is the magnitude equals to 1 upon 4 pi epsilon naught charge Q divided by R square. We have to need the value of R. This is the A sides, and try to find out this figure. So this is the A distance, also this is the A distance, also this is the A distance. Region due to this regular hexagon, this is the A distance, this is the 60 degree, also we can say this is 60 degree, also we can say this is 60 degree. Imply that for each triangle, these triangle are the equilateral triangle. They are the first equilateral triangle, second equilateral triangle, and third equilateral triangle, fourth equilateral triangle, and fifth equilateral triangle. This is the first, second, third, fourth, fifth, sixth. There are the six equilateral triangle are given. So this is the A distance, this is 60 degree, implies that this is the 60 degree. This side is the A into sine of 60 degree. A distance is this is the A cos 60 degree, this is the A sin 60 degree, A sin 60 degree. A into sine 60 which will be equals to A into root of a 3 by 2. So this distance equal to this distance. This distance is the A into root 3 by 2. Implies that. Then 2 times of A into root 3 by 2. 2 cancel. Then equals to A into root of a 3 by 2. Implies that the value of R which will be equals to A into root of a 3 by 2. A into root of a 3. Only root of a 3. Not a by 2. So 2 times of A root 3 by 2, 2 cancel. This is the net electrical field E1. Similarly, we can say this is the E2 vector magnitude. Implies that because these distance are the equals to E3 vector magnitude equals to E4 vector magnitude equals to E5 vector magnitude equals to E6 vector magnitude. Implies that net electrical field, because we know that is net electrical field which will be equals to E1 vector plus E2 vector plus E3 vector plus E4 vector plus E6 vector plus E5 vector. This is the E5 vector, and even vector and this is the first, second, third, fourth. Even vector are equal and opposite, means magnitude are equal and direction are opposite. So we can say even vector equals to this is the minus E4 vector, imply that similarly these vectors are the equal and opposite, imply that these r vector are the cancel out. So we can say these equals to 0 vector. We have to note the net electrical field at point O, which will be equals to 0. So A option is the correct option. Option A is the says that if X charge equals to Q, then net electrical field at point O which will be equals to 0, because X assume that the Q charge. So net electrical field at point O equals to 0. Similarly, we can say by checking the second option is the says that is the second option is the if X equals to minus Q, then net electrical field at point O. If X equals to minus Q, if X equals to minus Q, then first and fourth charge cannot be cancelled out, because due to plus first charge the direction of electrical field will be vertically downward, and due to the fourth charge the direction of electrical field also will be the vertically downward. So remaining electrical field will be cancelled out, because due to second charge the electrical field will be the away. Similarly, we can say electrical field will be the away. Due to these charge electrical field will be the equal and opposite. So due to the first charge and fourth charge the net electrical field will be equals to, so net electrical field which will be equals to E1 vector plus E4 vector. E1 vector plus E4 vector. The value of E1 and E4. We know that the value of E1 vector equals to the E2 vector, sorry, E4 vector, because if any two vectors are the equal, then their magnitude and direction will be the equal, or then we can say that vector are the equal vector. Let us suppose this is the first vector, this is the second vector. These two vectors are the equal vector, imply that magnitude and direction both will be the equal. If this is the first vector, this is the second vector, this is the magnitude are equal but direction cannot be equal. So this vector equal to minus this vector, implies that if A is this and B is this, then A vector equal to minus B vector. If this vector is the magnitude are same, also direction are the same, then A vector equals to the B vector. Imply that we can say A vector equal to B vector, yeah, even vector equals to E2 vector. This is the two times of a even vector. We know that even is this. Also we have to find out the even vector magnitude. 2 times of a even. This value is the 1 upon 4 pi epsilon naught q divided by r square. The value of r which will be equals to a into root of a 3 whole squaring. This is the value of r. A into root of a 3 squaring. This is the a squaring and this is the 9. This is the value 9. Imply that we can say this is the value spin. We have to require that number which will be equals to a into root of a 3 by 2. This is the charge q. So this is value will be cancelled out. This is the 2, 9 to the 18. So this number is the 1 upon 4 pi, 1 upon 2 pi epsilon 9 to the 18. So q upon pi into epsilon naught into a square. So according to the second option, Here the distance r which will be equals to, this is the r distance equals to root 3 into a. So this distance equals to root 3 into a whole squaring, then that number equals to 2 2 ja 4. This is the root 3 whole squaring equal to 3. 3 2 ja 6. This is the a into a squaring. Implies that q is q divided by 6 pi epsilon naught into a. So this is the net value of electrical field. So net electrical field which will be equals to q divided by 6 pi epsilon naught into a square. Also B option is the correct option. Option B is the saying that if x equals to minus q, then net electrical field at center of this hexagon which will be equals to q upon 6 pi epsilon naught into a square. Also, we have checking the option C. The option C is the says that if x equals to 2q, then V naught equals to that. V naught means potential at point O. Potential at point O. If x equals to 2q. If x equals to 2q, this is the 2q, then potential at these situations, the value which will be equals to, if x equals to q. Here this is the first charge, second charge, third charge, fourth, fifth. This is the similarly there are the sixth charge. We know that potential formula which will be equals to V equals to 1 upon 4 pi epsilon naught q by r. Q by r. This is the charge with sign. Charge with sign. Charge with sign, and this is the r distance. Distance means the distance between the charge and that point. We have to require the potential. This is the formula potential. Potential may be positive or negative because charge may be positive or negative. 4 pi epsilon naught is the positive, r is the distance is also positive. So potential may be positive or negative. Imply that we can say here we are using the tricks. There are the 6 charges, but this is the first charge, second charge, third charge, fourth charge. If we have to assume there are the 7 charge, because first charge q, second charge q, third charge q, spreading 2q charge in q plus q. This is the another fifth charge, sixth charge. If we have to splitting the fourth charge 2q equal to q plus q, implies that there are the 7 charges. Let us assume there are the 7 charges, means we have to need the potential due to 7 charges, and that is the equal distance. Implies that we can say if we find out the potential due to first charge, or we can say due to single charge, then that multiply is the number is the 7. Then 7 into 1 upon 4 pi epsilon naught q by r. The value of r equals to a into root of 3. That number equals to a into root of 3. Then this is the net potential at point O. Net potential at point O, which value equals to 7 into 1 upon 4 pi epsilon naught q divided by r a into root of 3. So this is the C option is the also correct option. If x equal to minus 3q, if x equals to minus 3q, then net potential at point O. If x equals to minus 3q, then 3q means this is the minus 3q. If x equals to minus 3q means we know that potential will be, if q is the positive, then potential is the positive, q is the negative, then potential is the negative. So due to minus 3q charge, minus q, minus q, minus q. So potential due to plus q and minus q will be cancel out. So also we can say plus q and minus q will be cancel out. Also due to third, plus q and minus q will be cancel out. So first charge will be removed, second charge also removed, third charge also removed, and fourth charge also removed. Then we have to only save the sixth and fifth charge, which is the Q charge. Implies that V net potential at point O equals to, this is the 2 charge, then this is the 2 times of 1 upon 4 pi epsilon naught Q divided by R. R is the A into root of 3. Imply that we can say this is the 2 divided by 4 pi, or we can say 2 cancel, then 1 upon 2 pi epsilon naught Q divided by A into root of 3. So D option is the correct option, because in D option negative is the given, so we can say due to negative charge, so D option is the incorrect option. So option will be correct, the A, B, C. Only 3 option is the correct, A, B, C. This question is the advanced 2022 questions.